We're moving on to 11.4a. Are you going to be able to take notes like that?
Yeah.
There's writing in this one. You're writing sentences today.
Yeah, I have my pen.
Okay.
My paper.
All right, so we're going to get started. So we're going to identify binomial experiments today. So in each question on a multiple choice quiz can be thought of as a trial with two possible outcomes, correct or incorrect. If a person were to guess on each of the 5 questions, the probability that he or she answers the question correctly is the same on all 5 questions. Guessing on each question is an example of a binomial experiment. So a binomial experiment is the probability experiment that satisfies the following conditions. Okay, so there is a fixed number of independent trials n. So you have n amount of trials that are independent. Okay, they don't depend on something else to get that probability. Each trial has only 2 possible outcomes. Okay, so you have your 2 possible outcomes. One is a success, the other is a failure. The probability of success is P, okay, is the same in every trial. Okay, so that probability of successes has to be the same for every single trial. It doesn't change once you take something away. And the probability of failure is Q. Okay, so that is 1 minus P. So you'll have P as your probability of success. To find your probability of failure, you just take 1 minus that P value. Okay? And then the random variable X is the number of successes in n number of trials. Okay? So many probability experiments are or can be reduced to binomial experiments. Okay, so we have a few listed here in example 1, and we want to identify if it is a binomial experiment or can be reduced to a binomial experiment. Okay, again, meaning it has 2 possible outcomes, a success and a failure. So if it is a binomial experiment, we need to describe a trial. Okay, so this is if it is. If it's not, we don't have to do this part. So if it is, describe a trial, determine the random variable, and then state n, p, and q. Okay, again, n is your number of trials, p is the probability of success, and q is the probability of failure. So letter A says, in a class that consists of 12 male and 13 female students, a group of 5 students is randomly chosen to see how many males are selected. Now we have to decide if this is a binomial experiment. So if I take 1 student to make that group of 5, does my probability stay the same that I'm going to select a male student? Okay, will your probability remain the same if I take one of those students away? Anybody listening?
Makes sense.
Your probability is going to change if you start taking students away. Okay? Because you could have selected a male for that first randomly chosen student, and then your probability is going to change. If you select a female, now you have more chances to select a male. So that probability does change. So this experiment, yes, you are writing today,
We're writing today?
cannot be reduced to a binomial experiment. Because events are not independent.
Oh my goodness. Dang.
I told you you're going to write today.
Yeah.
Okay, so the probability of choosing a male student changes after each selection. Okay, so that's kind of what I was getting at before. So if you start taking away students, your probability of choosing a male for that random group of 5 is going to change, okay, because you're taking one of those students away. So if you notice your probability changes, it cannot be reduced to a binomial experiment. If your probability always stays the same, then it can be. Okay, questions on the first one. So that one cannot. Let you finish writing if you're not done yet. Okay, letter B, so our next example says a school study found that 65% of students have seen an episode of a specific show. 7 students are randomly asked if they have seen an episode of the show. Okay, so we know that 65% of students have seen this episode. Okay, so that's true for the whole school. They're choosing 7 students randomly and asking them if they have seen an episode of that show. So can this be reduced to a binomial experiment? Yes, it can. Your probability stays the same at 65 the entire time because they already have that statistic. Okay, so this experiment can be reduced to a binomial experiment. Okay, so if we decided that this can be reduced, what I underlined at the top under example 1, we need to describe a trial, determine the random variable, and state N, P, and Q. Okay, so our trial then has 2 possible outcomes, a success and a failure. So we want to state what the success is and what the failure is. Well, I'm asking students if they've seen an episode, so what would a success have to be? So if they say yes. Okay, so success is a yes. Meaning your failure is what? No. Okay, failure is a no. Okay, your trial a trial is just asking the student the question. So a trial is asking a student. Okay, so all you have to do is ask the student for that trial. And then we need the random variable. Okay, so the random variable is the number of yeses. Okay, so I have what a success is, what the failure is, what the trial is. It's just asking the student that question. And then your random variable is the number of yeses that you get. Okay? So last thing I need for this is to state N, P, and Q. So again, N is how many trials there are. So how many trials do I have in this scenario? Yeah, I think so. 7. Okay, so your number of trials, N, is 7. What is your probability P of your success? It's in the problem itself. 65%. So I'm going to write that as a decimal. Okay, so probability we want to write as a decimal because your probability has to be less than 1. which means 100%. Okay? The last thing I want to state is Q. So Q is the number or the probability of a failure, so probability of a no. So to get Q, we just take 1 minus our p-value, which is 0.65.
There's only one S.
That's cool. Thank you.
I looked it up.
Okay, so our Q value will be 0.35. Okay, so again, if this is a binomial experiment, which it is, you want to state what the success, what the failure is, okay, because you only have 2 possible outcomes. State the trial and the random variable, and then state how many trials, the probability, and the failure. Okay? And again, that will most likely be given to you in the problem itself every single time. Questions on letter B? All right, I want you guys to try C and D. So work together, figure out if that can be reduced to a binomial experiment. Okay, again, binomial experiment only has 2 options, a success and a failure.
That's no.
I got 107%.
Did you? Okay.
Yeah, I stuff some your grandma swiped up there.
No.
Like, hey grandma, I need to talk to you. Okay?
Yeah.
Yeah.
So
Yeah, I did.
34% of students are, so they already know what the probability of the entire school is. You have 75 students are randomly asked. So if you're asking somebody a question, you can, you're going to get 1 of 2 answers. So if you can split it into a yes or a no type of deal, then it's a binomial experiment. That's not answering the question.
Yeah, it is.
No, it's
It's 26. Why do you need to stop? Or hard? 75. Yeah, are we supposed to be doing this? That's what the answer is. That 34% of students own the cars.
You're supposed to be telling me if they can be reduced to a binomial experiment.
26. This experiment cannot be reduced.
be like night. You gotta go.
I don't know how to do this.
Were you listening to anything I said?
Look, I got the notes.
Did you listen to me as I talked about it?
I was driving down.
How's your lifeguard thing yesterday?
Okay, how? I've never swam much before my entire life. Yeah, we were literally in the pool from like 8 to 1. I've never swam. The last time I swam like a lap was when I was 8 in swimming lessons. Like, I don't swim. And
why did you become a lifeguard?
because I thought we were just doing this stuff. Like literally, I thought we were gonna like take a test or something. But we got there at 8 o'clock. He's like, okay, 12 laps. And he's like, no stopping. And I've literally never swum before my entire life. I thought I was in like the army or something. The guy, the college coach, that's like teaching our thing. And he's like, you can't stop front crawl, like no goggles. And that was just to get into the class. And then we had to like go get some freaking 15-pound brick from the bottom of the deep end. And we had to swim underwater and then dive. And I didn't know how to do any of it. And I literally thought I was like a Navy SEAL. Like I've never even done that in my life.
Get out of here.
What?
No.
I don't like McDonald's.
Yeah, you
McDonald's. You stole my reason.
He likes McDonald's.
McDonald's.
McDonald's. You know somebody stole Ronald from our McDonald's.
What?
You know Ronald?
Yeah, someone stole Ronald McDonald's from McDonald's.
That's weird.
Yeah, they found it at a campground. And then a week later, it got stolen again.
That's cool. All right. We're going to go over these two. So, letter C.
Come on, He walked away.
Letter C is a binomial experiment. Okay, so this one is a binomial experiment.
Binomial experiment.
Yep. So this one is a binomial experiment. So
Experiment is binomial.
a success is a yes. So if they answer yes to your question that you're asking, so if they own a car, a failure is a no. A trial is asking a student. Okay, so I have my success, failure, my trial. What else do I need? The random variable. Oops. And since Eric said there's only one S, I'll write one S.
Yeah.
Okay, so the random variable is the number of yeses.
That doesn't look right.
I know, it doesn't look right, does it?
Well, that's what I saw on the internet. Look, what is this?
Yeses. Let's just put yes.
Okay,
Oh.
what are the last three things I need? Since this is a binomial experiment, what are the last three things I need? N, P, and Q. What's N? What's P?
0.34. I don't know what P is. 0.66.
Good.
Oh my goodness.
Okay, so that one was because you were asking students a question. Okay? You can turn that into if they say yes and if they say no. Okay, that's why it's a binomial experiment. The last one, letter D. 4 cards are removed from a deck to see how many aces are selected. Hey, focus, please. So 4 cards are removed from a deck to see how many aces you pick out of that deck. Is this a binomial experiment?
No.
No.
It's not. Okay, so think about it. You have a deck of cards. There's 52. Shh. Hey, quiet so you know what I'm talking about, please. You have 52 cards in a deck. As soon as you take one out, your probability of drawing an ace is going to go up or down depending upon if you pick an ace right away. Okay, so your probability does change after you select one card. Okay, so this experiment,
Use the 1 minus thing.
no,
This experiment.
cannot be reduced to a binomial experiment. Okay? Oh, because the events are not independent. Okay, and like I said, the probability of choosing an ace changes after each selection.
That's the
Okay, so once you start drawing cards out, your probability of choosing that ace does change. That's why it cannot be reduced to a binomial experiment. Your probability always has to be the same in every single trial. So So every time you would take a card out, your probability would need to remain the same. Okay, any questions?